Hello everyone, my name is Kirill. I had the idea to break down some technology from scratch, that is, to create some kind of analog. Right now my attention is focused on React because, as I've noticed for beginners and even for those at an intermediate level, it's not entirely clear how React works under the hood. Everyone relies on the magic on this so-called virtual DOM, but how it actually works isn't very clear to people. Now we're going to make an analog, a maximally simplified analog, just to basically understand that libraries of this kind are actually quite easy to create and don't require a lot of effort. You can make something like this pretty quickly on the fly, at least in a simplified form. To start, of course, we need to take a closer look at how the virtual DOM works, and in particular React reconciliation. There has already been a video like this on the channel. In that one, we directly compared how React, Vue, and Angular work with each other. But I'll go over it again so that it's clearer and everyone is on the same page. Let's start with the fact that we have two trees. These are the current tree and the work in progress tree. Suppose at the stage right after we've rendered our data, we don't have this tree yet. So we've done our initial rendering and we don't have this tree yet. We only have the current tree, and this one can also be set aside for now. We've rendered, and let's say we have some inputs or groups of inputs here. It doesn't matter. We're typing there, entering a first name, last name, or maybe a middle name. Naturally, we're somehow changing our layout. At this moment, we create a work in progress tree. So the work in progress tree is already a tree that contains these changes. Next, we calculate the difference directly. So these nodes have changed, this node has changed. We break it down into small units, into small DOM operations, so that it's convenient to move them around. That's exactly what we've done. We've broken it all down. Then all of this goes into the fiber. Our fiber takes our small units and prioritizes them. That is, for example, if there's a lightweight task that can be done instantly, it will be executed instantly. If the task is more resource intensive, it will be executed a bit later. Why is this done? It's done to ensure high performance. In short and simple terms, this is how React reconciliation works. Now we're going to create something similar, but as simplified as possible, so you can understand how things like this work. I've already created the index, HTML file, and then the index.js file, and connected everything. There's also a div here with the ID root. Well, let's get started. First, we need to create an element class. So the element class. Next, in the constructor, we accept our attributes directly, meaning our tags, whatever our element will have. Tag name, class name, data on click. And we assign these as attributes. This tag name equals tag name, this class name equals class name. Next, this data here, it can be anything like text, anything at all, even a function. We'll handle all these cases later. It equals data, and we also process our handler, so onClick equals. Next, we need to create a render method. That is how our element will be rendered. We write the render method, taking container ID as an input parameter, that is where exactly we will render our element, the container ID. Next, we write const here. Actually, it's all pretty simple here. It's just like creating an element, adding a class, and placing it in the DOM tree. Create element. When creating the element, we insert the tag that we receive. Next, we add our classes to LM using class name. Then we simply add our data directly to LM via inner text, which updates the visible content on the page. After that, we proceed to add the onClick event handler function, enabling user interaction with the element. We need to check whether we actually have an onClick event handler defined on this object. To do this, we verify if the type of this onClick is equal to function, which means that onClick is indeed a callable function. If this condition is true, then we proceed to execute this function, allowing the onClick event to be handled properly. In summary, this is how the onClick property works. Alright, so if we click on our element, our onClick function that we passed in will be called. So far so good. Next, we'll actually place our element into our DOM tree. How are we going to do this? First, we'll use getElement by IDno. We don't need getElements by tagnamizo. We'll find our container by its ID and add our element to it using appendChild. Alright, we've got that set up. Next, we need to create our re-render method. So what exactly will be re-rendered? In React, it's actually much more complicated. There are keys based on attributes and all that, which could take a long time to go through. Right now, we'll keep things as simple as possible. We'll just use our data, meaning our internal values. And if they change, we'll re-render accordingly. Let's do the re-render. So the re-render method, we accept the text and then use document, get elements by class name, get the first element, and set its inner text to our text directly. Alright, our class element is ready. Next, we need to create something like our layout, where all the operations, comparisons, rendering, and so on will take place. For this, we'll create an HTML layout class. Here, we'll keep all our elements. That is, we'll store them as an object. All right, next we'll write the constructor. Basically, we won't have it accept anything. Let's leave it like that for now. Next, we'll create a function called createElement. Here, we expect a tag name, our data, and an object that will contain our values, meaning class name, container ID, and an onClick function. What do we need to do next? Our HTML layout class will be responsible for checking whether an element already exists in our DOM tree. Accordingly, we calculate the difference. If it has changed, we re-render it. If it hasn't changed, we don't re-render. But first, we need to retrieve our element. That means we need to refer to this elements. In elements, we'll store our elements will not be class name, meaning we'll store them by their class name. Yes, this isn't ideal. We could use some kind of hash to handle this better, but for now, we'll keep it as simple as possible by using the class. Maybe later we'll improve the way it works. Next, we need to check directly whether our data is changing or not. How can we do this? We take our data, we take our element, and we use the question mark operator just in case our element exists, because it might simply not be there. We take our data and compare it if it's not equal. Then inside our condition, we check whether our element actually exists at all. If it exists, we simply call a redraw or re-render on the element and pass the data to it. If our element doesn't exist at all, then we do the following. We create our element using new element and pass all the parameters to it. That is the tag name, then the class name, then the data, and our onClick handler. Next, we need to add our element directly to our elements object. We take this elements and add our element to our object using the class name as the key. And now we can render our element. We specify the container ID here. And finally, since we don't have JSX and basically aren't using anything else, we're writing everything from scratch. We'll do something similar to that. But first, we need to create a method called element, which we'll use to create our elements. We'll accept the tag name as well as basically everything else that we might need. But we'll also add an extra check there for safety. So class name, container ID. Next, we'll also accept our onClick handler again, just like in createElement. But here, we'll check if the type of data is a function, we'll execute our data. If not, then we'll create our createElement here and pass in all the same parameters. Next, we can already create something like our page. By default, let's create an index and write the class as index here. We'll inherit from tens from HTML layout. And let's say here, for example, we'll just be changing the count. Count will be set to 0. Next, we need to write an increment function that will change our count, and then a decrement function, and then we'll render something. And let's write our render method. Those who have worked with React in its class-based implementation will more or less understand the syntax now. If you haven't encountered this kind of syntax, the way things were done before functional components, it would be worth taking a look, because often in older projects there are parts that are built with class components. It would be good to know those as well. Let's take a look at our render method. Here basically we'll do things by analogy, just like in class components. We'll add a return statement. Here we'll already be creating some kind of element. That is, here we'll have an element with a div tag. Next, our data will already be our function directly, because here we'll actually be doing something nested and passing it as attributes. So we'll pass a class name here. Let's just call it main div, for example. Next, we'll also pass a container ID here as well. This is because we are rendering into the root. And for onClick, we'll just write null, because for onClick here, we'll directly create our counter and 2 buttons. We also create a div element. Here we write count, insert our values, and for this container ID, we'll write root. And for onClick, basically, there's nothing, so it'll be null. All right, let's copy it. We'll write 2 more like this. Just change here to button count increment. And here we'll write our 2 handlers. That is, we'll just insert them. Basically, if we change our count, nothing happens. When it comes to React, there's this idea that React is not reactive. Is funny as that may sound, but React isn't reactive for the simple reason that whenever we change any of our attributes, methods, or whatever, these changes don't happen on the fly. That is, Changes do not occur directly in our layout. Our data doesn't get re-rendered or updated the way it does in Vue or Angular. Where everything is reactive, in React it's not reactive because we have layers like setState, and only through that can we change the data that's rendered in our layout. And here basically it's exactly the same case, except here we call our render function. When we change our discount, for example, by adding 2 pluses, we want to re-render. We simply call this this render. And after we increment discount, we directly call our render function. It then re-renders. So basically, we're not creating anything new again. If we calculate any difference that is stored here, for example, if we change from 0 to 1, this element changes, meaning this particular field is updated. In React, this is implemented in a much more complex way. It also checks which attributes have changed and which have not. In the case where we change some specific text here, for example, we go here and check if our element exists, we re-render it. That is, we simply replace the text. If it doesn't exist, we add this element and then track it from there. But in this case, since it has already been created and is already present in our DOM tree, we simply redraw it. Other elements, however, will not be redrawn because of this. That is, they will remain on the page just as they were before. Let's save all of this, and now we can directly render it. That is, write new index. So new index, and from here we render. All right, good. We go over here and see that it has rendered. If we increment, we see that one is added to the decrement. The decrement isn't working for some reason. Of course, we are only calling render here. Let's take a look here. We do it, reload, and see increment and decrement. We go to inspect the code and see that, okay, let's go here. The root div, we see that we have exactly our 3 elements. If we increment, only this particular div changes. If we decrement, we see that again, only this div changes. Our buttons don't move at all, meaning there are no changes happening to them. The same thing will happen in the case of asynchronicity. So if we want to handle something asynchronously, we just call our render function again. How will this work? For example, in the constructor, so initially, as soon as we render our index page, we want to fetch some posts. Let's create a constructor. Next, we'll write a fetch wheel, use fetch with JSON placeholder to get the posts, and then we'll process them. So then we take our response, convert it to JSON, and then essentially we go one level deeper and actually retrieve our posts, that is the value, and we can in fact add them to one of our attributes or properties, post. And here we can already display our posts. How will we display them? Let's say we'll take our button again in posts, in this posts. All right, we'll display them inside a div. At this step, we'll write the title for our post, which means entering the main heading that will appear at the top of the post and let readers know what it's about. After that, in the class name field, we'll specify a unique class name for this post. For example, we can use the word post as the base class name and then add the post's unique ID to it, like post 123. This way, each post can be easily identified and styled individually in our code. And we've already written it like that. Let's see how this would work for us. Oh, we didn't call it here. Also, ideally, we need to refer to our super. All right, let's save, check, and we see that our posts have also been displayed. So we've displayed all our posts. Let's do increment and decrement. So basically, we've created something like a simplified version of React. This can exist. You can try to expand it, do something with it, but this is a very rough example of how it all works. Let's take another look at how it all works in practice. We have an element class. The element class stores all the information about our element itself. Tag name, class name, data, on click. It has 2 methods, render and re-render. Render is triggered when we draw our element for the first time. And re-render is used when we change our data. In our case, that's just the text. In React, it's more complicated, not just text, but also attributes, event handlers, and so on. Everything is more complex there. But in our simplified version, render is used only for changing the text. That's good. We've covered the class, or rather the class elements. Next, let's look at the HTML layout. Here, we store all the elements that we have on the page. We have a method for creating our element. Before creating it, we first get our element. Why do we do this? So that if we already have this element on the page, we can re-render it, because initially we check whether any value has changed in our case, whether the inner text of our element has changed. Then we check if this element exists. If it does, we re-render its value. If it doesn't, we create a new one, and then we save our element and render it. Next, we have the element method, which works similarly to JSX. Here, we accept exactly the same parameters as in create element. Only here we will compare. For us, date is either a function or not a function. If the data is a function, we call it directly because we might have false entities, as in this example. And then if we've called it, we proceed further down. So, for example, we've called it, and below we have similar elements. In other words, this element method is also called here. But in the case where after calling our function, when we have a function here after the call, we get our elements, we check and see, okay, here the data is not a function, it's just a regular value. Accordingly, we create an element and then check. If this element already exists, we re-render it. If it doesn't exist, we render it. All right. Next, let's take a look at our index page directly. Again, everything here is simple. Here we have a count. If we've already created all our elements, we record the values here, and here we write down our unique class name because that's how we can distinguish them. Well, you could get creative with it. Honestly, you could make it look nicer, but I did it this way to keep it as simple and quick as possible. I wrote out our elements, set the internal values, and also added the handlers. And here, when we change our count, we directly call our render function. In other words, we re-render all of this, our entire tree. Well, we don't re-render our entire tree, we only re-render the specific parts, or rather the elements that have changed. So in the case where we trigger a re-render, if we change our count, for example, re-render just this particular element, everything related to the posts that are displayed will remain unchanged. So if we open the code inspector now, we can see that our posts are rendered and only our count is actually changing. We don't touch the post at all, but it still takes quite a bit of time to reconcile all of this. But as a simplified version, we have replicated this React reconciliation. It's more or less similar, maybe a bit hacky in some places, but still, we've created a small analog. The code from this video will be in the description. You can check it out and play around with it. And of course, I'd really appreciate it if you subscribe to my GitHub and give stars to the projects you like. That's basically it. If you have any questions, feel free to write them in the comments. I'll try to respond as quickly as possible. Thank you all for watching. Please like, subscribe, and share with your friends.